You are given this equation which is in rectangular form, and then you are told that you have to convert it to or transform it from rectangular form to polar form. As you can see here, I've drawn the diagram to express how is it going to look like. So as you can see, it falls under the second quadrant. Okay, so first thing that we're going to do is to find the modulus or the radius or the distance, so which can be expressed in the form of z. Modulus of z is equals to the real part squared plus the imaginary part squared. Okay, so what you're going to do is that we only take the values for real. We see we have -1 squared. For imaginary we have 3, then you square it. Okay, and then 1 squared, -1 squared is going to be +1 plus 9, and then we're going to have the square root of what? Of 10. Okay, and then we are now going to find the argument or the angle, which can be expressed in this form: tan inverse or inverse of tan, then the opposite, which is 3, then our adjacent, which is 1. Let's take it as positive for now, and then the inverse of tan 3/1, or the inverse of tan 3, is going to give us 71.56 or 57 when we round it off. Okay, let's just take it as 72. Okay, knowing that our angle, we are not done, it is falling under the second quadrant, we are going to subtract this value from 180. So we're gonna say theta is equals to 180 subtract our value. I'm sorry about the marker. And then we are going to get 108. Okay, so this 108, we are going to convert it to a radian, then we multiply by pi over 180. So we're going to say that, and then we get our value. Here's 3/5 pi. And when we write our rectangular form equation in polar form, is going to be z is equals to, let me just write the general, which in most cases it is expressed in this form: cos for the real part plus usually the imaginary part goes with the sine. Okay, so it goes with the sine theta. So our expression in full polar form, our modulus there will be 10, then cos 3/5 pi plus I sine 3 over 5 pi. I hope you can see it very well. So this will be our polar form.